Good morning. As you're all here on time, let's start early because it's empty outside. Thank you very much for being on time, and that's what we'll try and do right through the day. It was a very productive day yesterday. We got close to a kind of sense of takeoff. But I need to keep reminding you why you're here. And it's not just a theme of the conference, it's a kind of mission of the conference, given we're talking about navigating the climate challenge and making big differences. I'm going to remind you what we were saying, what was being said to you yesterday morning, to help keep you focused between now and, say, 5 o'clock before the gala dinner, about where you need to take things and what you need to be thinking about, and what should be driving you, because that's why you've come here. Remember what Ian said right at the beginning, that a 30% reduction by 2030 is possible. Amma said it's doable, it's done, it's tried, and it's proven. In other words, we're not entering new territory. It's about adapting to what is possible. We heard from Amir as well about the issue of leadership, which came up time and time again yesterday. And Emir said, we have to be honest, as an industry, we have not done much for climate change. We have not done our job so far. We have not done our job so far. So this was not just a call to action, it was really saying you're underperforming given the public expectations out there. And we heard from Mahendra yesterday as well, that this is not just about profit. It's about creating sustainability and a community. And we heard the work that he's doing, particularly on CCS, the CCU plant that he's developing, and he says is commercially viable. So I'm reminding you here because through the day we want to keep coming back to you, to ask you where you're going, how brave you want to be, how bold you want to be. And I think Matthias put it absolutely correctly towards the end of the day. This is not about threats. It's about seeing new opportunities. And I can tell you in all our work for thinking the unthinkable, that is exactly what we see time and time again. The need to see this kind of thing, not as being pessimistic. And I say what I said at the beginning yesterday, it's about realistic. I want to get a mood. Ricardo, we were talking this morning. Just give us a sense of what you felt in your workshop yesterday, because we've got plenaries at the beginning of the afternoon, and let's feel that there's a driving force forward in line with what Amma and Emir and others said yesterday morning. But your reflection, please.
Hello. Hi, this is Riccardo Stoppa, GCP Applied Technologies. So yeah, yesterday I was pleased to have this conversation on Workshop 2 on the role of chemistry in order to help with the CO2 reduction in cement plants and overall, in concrete in more in general. I think it was an excellent discussion, many presenters showing the potential solutions and the extent by which we can reduce CO2 emissions. What I personally, as an expectation for today, I would like to hear from the producers, from all the stakeholders here is really what is the main barriers? What is that is preventing to take an immediate step today on that 30% of process optimization in particular, and how we can move forward together as quickly as possible.
So what is preventing them, or what is blocking, or what is not blocking? Maybe it's just in the mind at the moment. Thank you very much, Ricardo. And maybe I'll come back to you and you need to say, I'm still not hearing radical enough views through the day. So what we have this morning is a number of presentations, but it is designed to keep moving the train forward, threats becoming opportunities. And you can see we've got two opening speakers. First of all, Sherif Elsayed-Ali, welcome Sherif, who's going to talk about AI for optimization. And then Dirk Lechtenberg, who is going to talk about carbon reduction from alternate fuels. Putting on your agenda new ideas, new possibilities, new opportunities in line with what Matthias was saying yesterday. So Sherif, founder and chief executive of Carbon Re.
Thank you very much. Thank you. Hello, everyone, and good morning. Just wanted to start with a couple of things. One of them is there was all the talked about a lot about leadership. Amr talked a lot about it. Ian talked a lot about it. And what I want to start with is just to congratulate both because they have not just talked, but they have walked the talk. They have brought us together. They have driven the conversation, led this conversation, and really driven a lot of really important reflections yesterday, and I'm sure as well today. So just first of all, just want to thank you for your leadership, Ian. And Amr, who I can't see at the moment, but please pass on the message. The second thing I want to do is just ask you a question. Who is using AI at the moment in their company or an AI solution? So a few people.
A handful.
Who is, well, a handful at most. Who is not using AI at the moment but is thinking of considering that it might be useful in the future? A bigger handful. Great, fantastic. Thank you very much. Okay, so I'm Sherif Elsayed-Ali. I'm CEO and co-founder of Carbon Ray. Two others are my co-founders are also here today. So I will start, if I'm doing this right. Did I turn it off? No, I didn't. Okay, so Carbon Ray, we are helping the cement industry decarbonize today. We are an AI company based out of London, but operating globally. Am I doing something wrong? I'm supposed to press the green one, right? Green one? Anyone? Yeah, thank you. Okay. It's a bit embarrassing when you're a tech company and you can't even use a clicker.
The AI is failing.
The one in this head is failing for sure. It's the green one?
The top one.
The top one, okay. It's just terrible. Okay, so we are an industrial AI company that spun out of Cambridge University and UCL, and we're specializing in artificial intelligence. I'll talk a little bit about that. But our main product today is called Delta Zero, and essentially we believe it's pushing the boundaries of artificial intelligence to help cement producers unlock their data and achieve efficiencies that could not be achieved before today. But just let's do a recap and about cement. So we know that it's a priority. You know that cement decarbonization is a global priority. We know that's extremely important for sustainable development. But also this quote from an editorial in Nature, arguably one of the most, probably the most important scientific journal in the world from last year, saying that concrete buildings are versatile and long-lasting, and they're ideal for climate-resilient construction, but acknowledging the carbon footprint and the importance of reducing that carbon footprint and helping decarbonize cement. But we will need it in large quantities in the future for a very long time. So it's a absolutely important material, and it's absolutely important to decarbonize. And the cement industry is one of the leaders in the business world in leading for pledges for decarbonization by 2050. And reaching net zero. There was a question yesterday about net zero, and we know that term has lots of problems associated with it. So if we go back to what needs to be done today, we go back to that concrete goal of reducing emissions by 30% by 2030. That's a really good concrete way of doing things, of acknowledging the urgency of the climate problem and the urgency that creates, not just for the environment, but also for business. So that challenge does feel daunting, right? It's hard. We're in 2022, end of 2022 coming up. It's going to be 7 years to reduce emissions by 30%. That's hard. Where do we start? And we've heard today, yesterday, and we're going to hear more today, there's lots of opportunities about the leadership of taking advantage of these opportunities. One of those, and sort of where kind of how we're thinking about this, and one of the ways we can make a big difference today is by looking at cement operations today. And we know, everyone knows that kilns have good days and bad days. So in some days, the energy usage is better than others. And the reality is, if you look at the data, a typical difference between a good day and a bad day, you'll find somewhere as high as 10% in CO2 emissions. Can we make a difference there? Can we start using that variation? And that variation, a lot of it has to do with with what happens in the pyroprocessing. So this is where I believe AI comes in. AI helps us control that variation and reduce it and achieve those savings. Now, let's talk about what AI is and why it can be very useful. So you see two things. One, a real image of an operating room. A control room, and within that, the reality is, at the end of the day, operators are, despite all their expertise, despite all their capabilities, they are humans, and they're faced with huge amounts of data. And that data has done nothing but increase massively over the last 10 years. The more sensors you put, the more IoT you have, the more data there is, the more streams there are, and the more things that have to be managed, monitored, and controlled. And so, like in every other area of life, there is that information overload. There is too much stuff, too much data points. And one of the big problems with IoT and with that industrial revolution with IoT that we've seen in the last years is that, yes, we have all that data, but what do we do with it? Data that's sitting there doing nothing is not useful. So what's artificial intelligence? Yesterday I did a little bit of a talk about AI, and if you were there, you will have sort of seen me talk about. There are so many definitions of artificial intelligence. If you ask 10 people working in AI what AI is, they will give you 10 different definitions. So what I do in these cases is go to Wikipedia, because Wikipedia is sort of almost the sum average of human knowledge in these cases. So it's a good starting point. But this is a very good, simple definition. It's intelligence demonstrated by machines, essentially differentiated from natural intelligence that's demonstrated by humans, but also by animals to a lesser extent. And the research in AI is about studying intelligence agents, which are essentially software systems that are able to perceive something in the environment and take action in that environment. Again, you will have heard lots of terms like machine learning, artificial intelligence, supervised learning, reinforcement learning, deep learning. All of these are, this not the place to go into all this detail, but broadly speaking, the main point here is that all the major advances you've heard about in artificial intelligence over the last 10, 15 years, everything from navigation in Google Maps to Siri to any sort of image recognition has happened with something called machine learning. This is where machines learn from data and improve over time. This is very highly differentiated from previous generations of AI, something like expert systems, for example, which are a rules-based system, which essentially work like this. If this happens, so it's something that's coded by a human. If X happens, do this, do Y. If this value is over X, do this. If it's under, do something else. They work in certain circumstances, but they're also quite static in their capabilities. We specialize in something called reinforcement learning. Reinforcement learning is different to many other parts of AI in that it works based on creating a virtual environment that represents a real-world environment. So the virtual environment, for example, for a cement kiln, would mimic the physics of the cement kiln, what happens within that. And then you have AI agents, so it's essentially software that is trained on that environment to learn to improve itself and to arrive at strategies, including strategies to improve the environment that have not been thought of by humans potentially before. So really what AI does and what we aim to achieve is, starting with your data, is to understand the connections, to find how different things look, to group them together, to understand the linkages and the relationships between them and how they interact together. And that allows us to then really optimize things. Now, to prior processing, sort of quite, general figures, but something like 50% of the energy costs of cement production and 40% of emissions. So that's why this is where we started and where we're focusing on at the moment. And we know what the challenges are, and the challenges for an operator are huge. A cement plant is a highly complex environment where a lot of physical reactions are happening, a lot of things can go wrong, and a lot of things can affect the outcome and how good or efficient the process is. you have operators trying to balance competing requirements, and these requirements are increasing over time. Everything from costs to quality to uptime to throughput to emissions, and it's an extremely high-pressure job. And we know that it's very high-skilled, and that operators take, it takes years to become an expert operator, and it's not something that can be done easily at all. And within that, as with other industries, we know that software is there to help people and to support them in managing increasingly complex environments. Unfortunately, today's software predominantly in the industry has limited capabilities compared to what's possible. And so what we aim to do is to really unlock that value in the data. We talked about how much data there is, but also how that's, when you have data that's not being used, that's not very useful. And at worst, it can even be a distraction. So the AI analytics really are the route to be able to unlock the potential of that data and to unlock these efficiencies that exist within them. So more specifically about what we're doing, we are kind of using that state-of-the-art artificial intelligence to really harness that existing industrial data, so the data that already exists in plants, and use that to optimize fuel use, so that's resulting in immediate reductions in costs and in emissions at the same time. This is sort of a simplified example of sort of our main dashboard in our product, and essentially you see sort of that column in white in the middle shows you some of the recommendations that go to operators, and essentially recommendations for specific set points to optimize the production. And the goal is really to do two things: maintain throughput as required, as well as quality that's required, and within the operating parameters. And with the second thing is doing this with the least amount of fuel possible. A key thing here a key point here is that typically a process engineer can do a heat balance once a year. That tells them important things, tells them where the major losses are, but not how they change over time. We are able to do this in real time, meaning we can make every day a good day by understanding where the losses are and how to remedy them. So really sort of a recap here, summary. If you think of all the inputs, and these are some examples of things that affect the combustion of fuel in a cement kiln. You have things like the fuel mix, the fuel feed, the speed of the ID fan, the kiln feed, the kiln speed, all of these things, just some examples. And essentially each of them affects the other. They're all interrelated. And the difficulty is not to adjust one, but how to find the optimum adjustments for all of them together operating at the same time to get to that point where you have the right quality, the right throughput, with the kiln being stable and the least possible cost and CO2 emissions. And this is very much what we aim to do and what we do with our solution. Just one last point here on the, again, sort of how the interaction between sort of that kind of modern AI that we're using and expert systems is that an analogy I would make is that if you can think of an expert system as a cruise control, so you can put it in a car and that allows you to go at a certain speed, you kind of keep things stable. Essentially, our solution is more like a navigation system. And what's key here is that it's a navigation system for the operator. It's really helping the operator say this is the most efficient route to take for the least cost and if it was a car, it would be the highest, the least time. But in the case of a cement plant, so it's the least cost, the least emissions, and the best throughput and quality. So we work with both without and with expert systems. If it's in the case of an expert system, essentially we're feeding process variable settings recommended to the expert systems to implement. What we target is this, around 8 to 10% reduction in energy costs, 8 to 20% reduction in emissions. The difference here, if you see the gap between the 10 and 20%, is because if you are a plant that's looking to introduce or increase the use of alternative fuels, we can really help with maintaining the stability of the kiln with the introduction of alternative fuels, and then you get that, potentially that increase in emissions reductions with the alternative fuels. And we target, again, so hard to, obviously this is generalized a little bit, but between $3 and $10 million in annual savings per plant. That higher figure has more to do with places like Europe, where there is an additional carbon pricing, but we kind of 3 to 5 is an average for the rest of the world. Last thing, and this is a sneak preview, maybe a little bit something research we're working on. We'll be hoping to be talk to as many of you as possible over the coming month and hopefully publish early next year. But essentially, we're doing quite a detailed analysis of the potential impact of different technologies on decarbonization to 2030. And really looking at an optimistic scenario, essentially, if there is that leadership to really adopt and do what's possible today. So SEM really comes out on top in terms of potential, followed by biomass, but then very closely followed by AI fuel optimization, able to achieve somewhere something like an 8.4% reduction by 2030. And that's it. I'm very happy for any
Thanks,
questions.
Sherif.
Thank you. I hope I didn't go over time.
Anyone want to come in quickly, please, Amar? But I'm going to ask you the following, if I may, Sherif. Are you actually saying that it's impossible for cement companies to achieve what they need to achieve on carbon reduction and to take on the climate challenge without AI?
I believe so. I believe there's
Keep going.
Sorry, I believe there's a lot you can do without AI, of course, but there's a lot you cannot do without AI.
Because of the scale of the challenge to the human being.
It's two things. I mean,
operator.
and that's the reason we're seeing AI everywhere. And it essentially is that these are extremely complex systems, and the reason why we've seen AI being used across the world in everything from healthcare system to transportation is that it allows the understanding of those complex systems and reducing that complexity to something that can be actionable by people. And yes, we can do a decent job without AI, but we can do the best job with
But again, challenging you, I'm picking up your last slide, 8 to 10% reduction in energy costs, 8 to 20% reduction in emissions as well.
Yes.
You think that is unachievable without AI because of the scale of what has to be done?
Yeah, absolutely. Absolutely. I think, these are, the important thing to see is that these are not exclusive of each other, these technologies. So you might be able to introduce alternative fuels, LC3, and that will achieve its own reductions. But cumulative to that, doing that to the best possible way requires that boiling down of complexity to something where we can make the best steps on an hour-by-hour basis as we produce cement. And this is something that can only be done by AI.
Hello, Sherif. I have 2 comments and 1 question. The first comment is related to the last part you just said. What I think is, with AI, you are sure of the achievement. That's the point. Without AI, you achieve it sometime, and you might not achieve it at the other time. So the average is high. That's the real impact of AI. The second comment is really whatever we do of strategy of decarbonization and operational excellence, the whole company of a cement company is dependent on the quality of the kiln operator. And this is really a big problem in cement industry. We can make big strategies, big plans, but if we don't have a very good operators all over the day, all over the months, without their personal problems, their whatever issues, because they are humans, every effort that we do is dependent on the moment that he is controlling the kiln. And this is a big problem in cement industry, and this is why AI is very important, and machine learning is very important in cement industry to move forward on both operational excellence and consequently decarbonization. Those are the comments. The question is, usually we get the comment and the discussion in the cement industry that even at expert control level, you could find that most of the time put offline because things are unbalanced. Yep. And it doesn't work unless everything is in the right place.
Yep.
So with AI, what is the advantage on that? And the continuity of this question is, usually we face the resistance of the operators because we cannot pull them out of the loop. So when AI takes over, they are always resistive to that. So in your solution, I know that there is another side angle to this. So please elaborate.
In other words, does AI overcome the resistance of human operators?
Yeah, and it's a really it's a very important question, and I have to be super clear. Honestly, a lot of what we hear about AI generally in the media, a lot of the narrative is completely wrong, right? AI is just not anywhere near the capabilities of like overtaking humans or kind of replacing humans or anything like that. And this is not what it's good at. It's good at as a technology that assists people, that augments people, and that's how I like to think about it. Essentially, it's in the same way that computers have augmented our capabilities, calculators have. This is just an advanced form of that. And essentially, if you think about it, is that the operator is key. The operator is absolutely key and remains key. And what AI does is like, it's another tool in their arsenal, but it's a very powerful tool. It's a much more powerful tool than what they've had before. And what it does is really allow them that navigation, including in places where there is that instability. There are things are changing or things are not going as they're supposed to be, you know, or you're introducing new fuels, or there's a problem in the kiln, and it's not really clear what to do. And the real power of it is that, you know, as opposed to expert systems, which are expert systems do what they do, but they are static systems that can only react to very set parameters. Once you go outside that, the only way to do it is either by trial and error, or by being able to predict what will happen when you change settings. And this is what AI allows you to do. So it allows you to bypass that trying something and it doesn't work, and a few hours later you try something else. That it allows you to predict what's going to happen and to take that direction straight away.
Anyone not convinced?
May I add something?
Okay, please, one voice here, and then we'll move on to Dirk.
May I add something, Nick?
Could you just introduce yourself?
My name is Ahmed from National Cement Company Dubai. We had our share in experimenting the AI in our manufacturing system. So for us, the main challenge was the data quality, the quality of the data, because if there is a faulty sensor or if there is a bad day in the killing, the gas analyzer will get blocked, then we will get a very bad data, and then the predictive modeling will be upset and things like that. The second thing is the interoperability for the system, that all the departments or all the equipment need to be integrated in order to apply the AI, and this needs a substantial investment, which is in our case, because of the market situation and everything, this needs a complete upgrade of everything. Imagine that we are working from for example, 1968, and we have our equipment, and we have different department and different equipment from different suppliers. And then in order to implement the AI, you need to just have everything together. So AI will be an amazing and fantastic equipment for a newly implemented or commissioned plant, but for an existing plant, it's a big challenge.
In other words, can AI have good days and bad days as well as the kiln?
I mean, well, we try to make sure that doesn't happen. But
it's a vulnerability.
No, well, so there's two things here. So there's two things, and they're really important ones. One is that you really pointed out to something that's really important, and it's the data quality and dealing with data quality. And this is kind of when you go under the hood of AI, including every single application that you've ever used that you think works really well, including Google Maps, for example. To get to that point, there is a lot happening underneath so that it actually works well. And a very big thing with AI that we don't talk very much about, you know, outside the industry, is dealing with data and data quality. But not only that, because you know you're going to get data that's not very good sometimes, right? And you're going to have to deal with it. So, I mean, the amount of work we spent many, many months working on things like anomaly detection and data quality, and you know what to do when the data that you're getting is not good, and how to how to overcome that. So in the background, there's a lot of engineering systems, a lot of data engineering systems that are happening to be able to deal with that and be able to still work and have very good systems beyond that. The other thing is, the other part is really important, is that AI improves over time, right? So it's because the more it sees, the better it gets. That's kind of the general rule. But the key here is that we work with operators, and this is also, I think, kind of as to your other questions about how can you integrate that in plants that may have different systems from different times and so on, and kind of the need for capex. I mean, we see this as yes, in an ideal world, in a newly commissioned plant, if it's greenfield, you can go and set everything up and have everything working greatly from the beginning. But the approach we've taken is to actually do this as a recommender system for the operator. So the operator, at the end of the day, says if this doesn't feel right, they can choose not. They choose not to implement it. And we think that's the right approach today for two reasons. One, it can be implemented straight away because all you have to do, it's a browser-based system. You can open it on a tablet or on a computer screen, and you have it in front of you all day, giving you recommendations throughout the day, and you implement them. If something doesn't feel quite right, you can tell us, right? And you feed back to us and say, this is a little strange, and you can have that discussion. But at the end of the day, what it means is that all you need to make it work is to get a data feed from the plant, from the DCS, and then you get back the recommendation. So there's almost no integration or capex needed.
All right, let's pause for the moment and move on to Dirk, because this is about introducing you to new concepts. So we've got a stack of them lined up. Dirk, the floor is yours. Dirk Lechtenberg.
Thank you very much, Nick. I think artificial intelligence will be very important in the cement industry in the upcoming years. That's my opinion. We are already using artificial intelligence and introduce it in waste management, waste processing facilities. They can identify different types, even of brands on the conveyor belt. So when you're processing waste, the system can identify the different types of bottle and can separate the different types of bottle, the brands, even the brands. But coming back to my topic, very simple. Everybody's doing it, everybody's producing it. We're speaking about waste and the role of waste or alternative fuels in times of circular economy. Reimagining alternative fuels in the era of circular economy. I will do a short introduction about myself and our company before I deep dive into alternative fuels. Our company, MBW Lechtenberg and Partner, based in Germany, is working on the implementation and developing concepts for the use and production of alternative fuels. We have done so far projects all over the world, in the cement industry, lime industry, steel industry, for governmental organizations, just recently in Saudi Arabia for the Ministry of Energy and others. In our projects, which we have developed in the last 25 years, which are more than 100 projects worldwide, these projects producing every year around 900,000 tons of RDF, of refuse-derived fuels. To give you an idea, this is a truck curve from here to Muscat, 500 kilometers every year, which saves around 6 million, or which is sequestering the carbon from around 6 million trees. 1.26 million tons of CO2 emission savings every year. That's a big number. On the map, you can also see the countries where we developed such projects. In the last years, we have focused on the Middle East, where we developing such projects. Our handbook, which my colleague and I has edited a few years ago, you can find meanwhile in almost every second cement plant in the world. We're organizing workshops on alternative fuels, processing alternative fuels, influence of alternative fuels in the cement industry. The next one will be next week in Barcelona during the Semtec. We're also doing our own conferences, the Alternative Fuel Symposium, and we are not only in the theoretical consultancy, we're developing projects by ourselves. We are supplying cement plants, we have own alternative fuel production facilities, one in the north of Germany with a production capacity of 150,000 tons. We are recently building another one in my hometown in Duisburg with a capacity again from 150,000 tons of alternative fuels. And we are also operating a facility in Riyadh, in As-Sulay, together with local partners. And we recently started in India, where we signed an agreement with the city of Delhi to take the first 50,000 tons of legacy waste from Okla landfill to dilute the waste on the landfill side together with a local cement group. What are alternative fuels? There's a definition according to the World Business Council for Sustainable Development. These are selected waste and byproducts with recoverable calorific value which can be used as fuels in a cement kiln, replacing a portion of conventional fossil fuels like coal if they meet strict specifications. So it's not only waste. These are separated fractions of waste, of mixed municipal solid waste, of industrial waste, even of hazardous wastes. They can be solid, they can be biomass derived, like wood, rice husk. They can be also hazardous and liquid, oil, solvents, and many other things. This morning I had a discussion about spent cell liners or spent pot liners from the aluminium industry, which are widely used in the cement industry. So whatever we are using on alternative fuels have to meet strict quality requirements. Why? You are cement producers, you want to produce cement, and you're not a waste incinerator to burn all types of waste. So the product quality is the main driver and the influence on the environment. So we have to avoid any negative impact on the environment by using alternative fuels. When you look at the total alternative fuel mix and fuel consumption worldwide, I'm sure you know all these numbers, you will see that Europe is the main driver for alternative fuels usage. Most of the alternative fuels are used in Europe. When I started working in a cement plant 35 years ago, that was the first cement plant in the world which was processing municipal solid waste into alternative fuels. A very small company which started this use 35 years ago. Nowadays, we assume that the total alternative fuel consumption is around 35 million tons. There's no clear statistics about the use of alternative fuels because there are also different synonyms for the use of alternative fuels, such as biomass or other things. But you can see with the use of alternative fuels in a higher substitution rate, let's say 30%. From our experience, it's possible to use 30% alternative fuels in almost every cement kiln. And assuming we are replacing coal and taking the current clinker production capacity of around 4.5 billion tons, the calorific value which we assumed is a bit high with 800 kilocalories, should be a bit lower, but to take an average. We could replace around 350 million tons of coal a year if we go to a substitution rate of 60%, which is common practice and best practice in Europe. This is equal to around 480 million or 500 million tons of waste-derived fuels. This is a big number. Nick, you are looking at me.
Correct.
Astonished.
No, not, well, partly astonished, but keep going. I'm only looking at you as you speak.
Yeah, thank you.
There's no message
Good.
yet.
Everybody will say, yes, that's easy to use 60% or to get 60% substitution rate If you are located in Germany, where you have a proper waste management system, the Germans are separating all the waste in 3 or 4 or 5 different bins. In Saudi Arabia, it's completely different. Let me go back. In Saudi Arabia, it's completely different. Yes, it's different. But even in Saudi Arabia, you see in the composition of the waste that there are a lot of calorific valuable waste types, like textiles, wood, plastics, paper, cardboard. Theoretical, we could separate these high calorific valuable fraction and produce and separate around 40%, no, 39% of alternative fuels. But we don't want to take out the plastics, which we can recycle. We don't want to use paper in a cement kiln, which we can recycle. So when we are building such sorting facilities and processing facilities, the main goal should be to separate whatever can be recycled and only to use the remaining non-recyclable parts, the compound materials, the mixed materials, which are dirty and not recyclable, as source for RDF. And in each country, it's different. Here you can see the example from the kingdom. In India, it's again completely different. The waste generation per capita is much lower. And the content of recyclables is much lower. Why? The waste is always a mirror of the society. As richer the society, as more waste is produced. You have to look into the waste bin of somebody to see if he's rich or poor. In rich societies, the people are throwing much more waste away. Everything is packed. In Europe, you have a lot of single households, and everybody is buying 4 slices of cheese in a plastic packaging. You're smiling. Own experience. So, as richer a country, as more waste is produced, and as higher is the value of the waste. In calorific value, but also in the recyclable value, in the circular economy, by taking it back and using it. In the US, the same. We're currently developing a project together with the Cement Association in California. There's a lot of plastic in the waste, a lot of paper, a lot of recyclables. Again, theoretical, 60%, almost 60% of the MSW would be a high calorific valuable material for the production of RDF, but we don't want to separate the plastics and burning them. We want to separate it for recycling, either for the material recycling, to process a PET bottle into a new PET bottle or other PET products, or for chemical recycling, which starts now in many countries. All the big petrochemical companies are starting now processing plastics, polyolefins, into new plastics. Polyolefins into oil, and from the oil they're producing new plastics. And the petrochemical industry is currently making massive investments in such facility. Our facility in Germany, we are separating the polyolefins from the mixed waste stream. And all the polyolefins are pelletized and delivered to such projects from Dow Chemicals, BASF, SABIC, Neste, and they're planning massive investments. So the question is, who will get all the waste? If the chemical industry is looking for the waste, if the cement industry is looking for the waste, I think it will be a cooperation. Because the petrochemical industry is only interested in polyolefins. We are interested in non-recyclable, high calorific valuable waste. So there's a good opportunity to work together and to benefit from each other. This will be a part of the support for a circular economy. The L. MacArthur Foundation defined circular economy as a systematic approach to economic development designed to benefit businesses, society, and the environment. So it should benefit everybody. When you look in the waste hierarchy, I think you have seen this many, many times. For us humans, it's important to avoid waste. So whenever you are looking for products, the best thing is not to buy these products. Or when you have this glass bottle is much easier to recycle and can be refilled. So if you have the choice to take a plastic bottle or a glass bottle, mostly it's advised to take the waste bottle. So avoid the waste. Then the preparation for reuse. The producer of the products have to take care that the products which are selling can be recycled. If I buy a mobile, the old mobiles were lasting for 10 years, no problem, or 5 years, no problem. Today, a mobile phone or a washing machine, after the end of the guarantee period, is mostly gone. My own experience, it's my own experience, but I think everybody knows that these products only have a short lifetime and that they cannot be repaired. The next step is the recycling. So when we are processing municipal solid waste, we should separate everything which can be recyclable before it can be turned into other recovery operations like co-processing or processing waste into alternative fuels. Because alternative fuels is not a recycling, it's a recovery of the heat, of the calorific value, but not a recycling, because when we have burned the material in the kilns, they're gone forever. So, co-processing waste is a recovery operation and recognized by all governments in the world, by the IFC, by the World Bank, as environmental friendly option to process non-recyclable waste and to substitute fossil fuels. How does it look like?
I'm looking at you now.
That's good. This is a picture of typical SRF, solid recovered fuel, or refuse-derived fuel, or alternative fuel. For me, it's shredded waste. But you can also see that by processing this waste, by shredding the waste, there are a lot of recyclables inside. So by the separation of recyclables like plastics, paper, metals, and other stuff, we can support the circular economy. And we are only taking the parts which cannot be recycled. That this is beneficial, I think everybody knows it. The main driver for the use of alternative fuels when we started 30 years ago in Germany was saving money. To use waste as fuel instead of coal. And this is still the main driver in many countries. And we still see that companies with increasing electricity and energy prices are thinking, oh, let's start with alternative fuels. But I also see a lot of member companies from the World Business Council and from the World Cement Association, which are doing a lot of effort in using alternative fuels despite the economic background. Like in Saudi Arabia, I mean, if you get a ton of heavy fuel oil for, I don't know, $30 delivered at the cement plant, why should you take care about alternative fuels? It's mainly to support the environment, to save fossil CO2 emissions, to develop a circular economy, to do something good for the environment. You still can profit on it if you are currently having high energy prices. This is a standard simple calculation just based on the calorific value. a typical 5,000 TPD plant, which is using alternative fuels, let's say 30%, which is standard, which can be achieved easily, is saving or has a potential revenue of $4 million compared to a coal price of $300. I don't know what's the coal price in the moment in this region, but I guess it's in this range. So even starting a project for using alternative fuels, investing in such installation is profitable, mainly for the environment, but also on the economic side of view. There are also some additional benefits depending on the region. In Europe, there are the carbon CO2 prices. Current price is around $70 or $75. So if you don't have enough allocations, that's an additional benefit of $4 million per year. So it's highly profitable. But it's also good for the environment. Again, when we look at the typical substitution in the German cement industry, so far it saved around 2.3 million tons of coal and reduced the fossil fuel-related CO2 emissions by 0.7 tons of CO2 per ton of alternative fuels. And I think with these words, I can end my presentation, Nick, exactly in 10 minutes. It's a win-win situation. To use alternative fuels, it's good for the society. It's providing a waste management solution. It's beneficial for the industry and mainly for the ecology by saving landfill space, avoiding landfill gas emissions, reducing the carbon emissions, and supporting the local governments and municipalities. And especially in developing countries, we have developed a lot of projects where small municipalities got the support from the local cement plant in developing waste processing facilities, creating jobs, and doing good for the society. Thank you very much.
Thank you, Dirk. I'm very struck. It's not just a win-win situation. You say it's a win-win-win situation. Picking up on what Ricardo said, what is preventing people doing this? And I quoted yesterday, I think his name is Anderson from Holcim, who said we as cement manufacturers are now becoming significant waste handlers, and we have to see this as a central to what our mission is. Is that the way you see things moving and at some speed at the moment?
Yes, clearly. I mean, I'm working in this field since 30 years. I remember my first presentation at the Arab Union for Construction and Building Materials 20 years or 22 years ago in, I think, Algeria. I was speaking about alternative fuels and everybody was looking at me and didn't understood what I'm meaning. Nowadays, everybody is speaking about alternative fuels. It's a long-term process in each company to develop such projects. Because the kiln operator, which is operating the kiln, is lazy. Why should he change from oil or gas or fine grinded coal to waste materials? It's more work. It's more complicated. So it's a laziness of the people and of the organizations to hold on the old business model, and it takes decades for cement groups to develop the strategy and the philosophy in using alternative fuels. So training for the local people, to involving them to say, look, we start to use waste materials. We are processing alternative fuels because it's good for the environment and for the company and for your job. This is the main point. And it will become a main topic within the next years because it's necessary that every cement plant starts the use of alternative fuels in order to reduce the carbon footprint.
Thanks. Can I just check with our colleagues over there, the AV colleagues, do you have connection to Tao Junpu? We've got a virtual coming in. Have you got that? Because that'll affect my timings here. Has he dialed in yet? There's a bit of mystery here, Ian. So, yes, it's before 11 o'clock. It's immediately after Dirk. Yeah, on my list anyway. Please, if someone could just confirm, because 10:30. Okay.
Thank you. So Dan Samabel, also from Carbon Re. I think the presentation had a really good demonstration of the value of alternative fuels, both as a cost saving and a carbon saving. And certainly at Carbon Re, we see that. We also see the challenge, which is cement producers are being asked to go from a very consistent fuel mix to a very variable one that might be changing day to day because of the quality of the RDF, or indeed because of the market having to switch between different fuels. And it's something that we see the value of artificial intelligence in helping cement producers deal with yet another variable. My question is, what are the fuel providers doing to try and feed data about their fuels, to get information about their fuels, to enable that, to enable AI-type control systems to understand the fuels, understand the performance impact they have on the plant, and thus get the benefits that you so eloquently described?
So far, most of the alternative fuel processing companies or waste management companies which are processing waste into alternative fuels, they have a strict quality management. The quality requirements for alternative fuels are very high in the clinker production. So the waste processor has to do on a regular basis a sampling and analysis of the material. What we are doing in our own facility, we have an online measurement with a Röntgen fluorescence analyzer, which is quite costly and quite complicated. But we are measuring on a steady base all the trace elements, ash content, chlorine content, moisture content on a steady base.
Good morning. Good morning, Dirk. This is Srinivas from JSW Cement here. So my question is, generally we were already interested to use more and more of RDF, but the RDF present in UAE is having a more chloride percentage. So if we go hard mill chloride above 1.2%, there is a blockage in the cyclones and those issues we are facing. So can you suggest what is the short term, this is with low capex, what are the systems available to overcome this issue?
I couldn't understand the whole questions. I only understood that you have a very high chlorine content in the RDF.
Yeah, chloride content is more in this RDF. So we are interested to use that RDF much and much more to increase our TSR. But what are the systems available to overcome the problems we are facing, like jamming issues and all those things? So can you suggest some of the systems which we can avoid these problems with low capex?
First of all, it's the quality management, the organizational structure. I've seen it in many cement plants. They were happy to receive materials with a very high calorific value, for example, shoes, from the production of shoes, or plastic labels or other things. So if you're receiving PVC-containing materials, you should not use them. This is the first. So you have to know what type of waste you're getting in. And secondly, there are a lot of systems available on the market with so-called optical sorting systems. These are near-infrared systems which are detecting the surface of the materials and which are separating PVC-containing materials.
Okay, two more. We're going to run over our break, and we need to put a headset on. Thank you, floor manager, for fixing all of this. Much appreciated. Two questions, please. Where are the microphones, please? Microphones? Oh, you have a microphone. Okay, go ahead, please. Go ahead, please.
Thanks, Dirk, for the highly interesting presentation. I recently talked to a corporate environmental manager of a big European cement manufacturer, and I asked him the question whether RDF should really be seen as a carbon neutral fuel if the biogenic content isn't really known. And he told me that his personal answer would definitely be a different one than the one from the corporate office. So what do you think about this? RDF, if
Dirk, can I just get the other two questions, because we're running out of time, and I want to get them in.
Okay.
And we do have our signal.
Okay, thanks Dirk for the presentation and happy to meet you since Corona time. I just would like to give comment about the success rate of the alternative fuel project you did, particularly in the Middle East, and for the project which is not performing well, what was the challenge and obstacle you faced? Actually, this is also my main topic in my paper today, but I need to know from the project you did, and I'm going to share mine also this afternoon. Thanks.
Okay, Basim.
And the other one too. Could you just pass the microphone across? Over there, left. Thanks.
Okay, thank you. I am Adil Gilzim, AFR manager of CIMAT in Morocco. So we have in CIMAT we have 2 cement plants, and we are achieving right now about 30% thermal substitution rates, mainly with shredded tires, with RDF, and with sewage sludge, dried sewage sludge. I just would like to highlight that, said like that, it looks easy to achieve such substitution rates. But in reality, there are a lot of difficulties. The first one, especially in our countries outside Europe, it's the supply of the wastes. It's difficult to get the wastes. This waste has to be prepared, and this preparation has a cost. The question that arises usually is who will pay the cost of the preparation of this RDF. And this cost of this RDF could be higher than the calorific value of contained in this waste.
All
so
right.
this is...
Okay, thanks. This is a very rich vein. I'm under time pressure, but Dirk, can you try and bring questions together, please?
Okay, there were 3 topics.
Yeah.
First topic, biogenic content. Yes, RDF contains some biogenic content. What does it mean? Cotton is biogenic. Paper, wood are biogenic. So this is the biogenic content in the RDF fraction, which counts to reduce the fossil CO2 emissions. Even with the new legislation, the RED 3, which is coming out now with the first drafts, it's clearly stated that this biogenic content is carbon neutral. Most important is to have a good measurement on this, and we have developed a guideline for the German Federal Environmental Agency how to analyze, to sample the RDF and to analyze it in order to count it in the yearly CO2 reports. So it will be also in future CO2 neutral. Second question was, I think, the main topic from CIMAT in Ascementimara, I guess. Who's paying for the waste, or how to develop a waste management system, an alternative fuel plant, if nobody is willing to pay for the waste? This is one. Or I've seen it in my own projects. It's very difficult to get long-term contracts with the municipalities. One. And secondly, there's a lot of corruption, and therefore a lot of multinational companies are not allowed to make any contract with a local municipality if there's any kind of corruption or smell in the background. So it's very difficult to convince the municipalities, not only the governments or local governments, it has to come from the people itself. Yeah? That they see it's good for the environment. I can give you a few examples in Egypt, in Port Said, Ismailia, where we develop projects. And the mayor, the people were coming to us later on and were thanking us. because we stopped the pollution. They were burning the waste and the smoke was coming into the city. So yes, it's difficult, but it's doable. It takes time. We have to push and pray all the time that it works, and then it will work. And from the economical point of view, it makes sense. As I stated in my presentation, the fossil fuel prices will rise further, for sure. They will not go back to the level before the energy crisis. So it makes, from the economical point and environmental point of view, sense.
This is a very rich vein for discussion. I'm reluctant to bring it to a close, and I need to thank Sherif and Dirk, but obviously they'll still be around and we can return to it later on in the plenary this afternoon. But this is a very rich vein and a very important vein as well. So can I thank you both very much indeed. I know that we have our virtual contributors standing by. So what we're trying to do is give you an overarching drop-in understanding of other options you have available to meet the kind of challenge we're meeting here to discuss and for you to take away. So thank you, Dirk and Sherif, very much indeed for the moment. Thank you.
Pleasure. Thank you.
Thank you.
Thank you. And could I... And if I could invite Loïc as well, Loïc Pottier of Fives FCB, welcome. We're doing a hot switch, and I hope that we're also going to be joined by Junpu, who's chief expert for Sinoma energy conservation. Welcome. And do you have him? Do you have our contributor? Do sit. Okay. Do you have? He's there. Good. All right. There are two of them. Right. Okie dokie. Can you hear me from Sinoma? Can you hear me? Good. Good evening.
Yeah,
Good afternoon. All right. Good. I just wanted to check we have communication. So stand by, because first of all, we're going to hear Loïc Pottier. Loïc, welcome.
Thank you.
Give us your thoughts, please, on CO2 abatement.
So, good morning, everybody. First, thank you, Jan, and thank you for the association to welcoming us today and giving us the opportunity to give you some highlights. The message I will deliver today will take some topics that have already been presented yesterday. The solutions for CO2 abatement already exist. They are available. Most of them rely on proven technologies and have been already implemented in different sectors, sometimes for different applications, but are fully adapted to our industry targets or ambitions in terms of CO2 abatement. And the second message is as well that we talk about massive investment, and typically our industry is really particular because each investment is significant, and even one single cement plant is, let's say, big numbers. And in fact, this solution can be implemented step by step. You can start with a small investment and increase, but then having a regular increase in your CO2 reduction performance. So that's basically what I will introduce today and detail at the second part of the presentation some of our solutions. So FIV-FCB is, let's say, part of the FIV Group. FIV Group is a quite young company of more than 200 years, which has crossed the different industrial revolutions. And what is happening today with the CO2, let's say, needs is a kind of industrial revolutions. So we went through the previous one, and we will go through this one. FIV-FCB is dedicated to the cement and mineral business in the FIV Group, and we are dealing mainly with the cement industry and the mineral grinding industry. And both are a little bit complementary. We are a member of different associations and organizations internationally, which give us a nice picture of what is happening everywhere. And we also face some difference in terms of languages, so I will try to avoid any, let's say, particular, let's say, concept to be well understood. We will start with this quite known scheme, which is a little bit outdated, and I will tell you why, referring to the abatement measures in the COP21 in 2018. We like this one because it divides the actions to reduce the CO2 emissions into families, and which are quite practical. One is the thermal energy efficiency, and we have talked this morning about intelligence, artificial intelligence, optimizations. So this is one family. Another one is the fuels switching. So Dirk this morning gave us very interesting insights on what are the potential of this. A third family was the reduction of the clinker to cement ratio, or increase of cement to clinker ratio. Depends the area, but so sometimes it's confusing. And the last family was innovative technology, which is today basically the carbon capture and storage. So I was telling that this chart is a bit outdated because the weight of these different technologies are now a little bit different. We all know that carbon capture is a quite expensive technology. And one of the messages we can spread is that it's better to invest in other technology to have a very small amount of CO2 remaining for capture and storage because of the high cost of this technology. I will share with you some, let's say, survey that has been done by the association that also split the different savings in terms of CO2 emissions in families. Also, one operational excellence is including the energy efficiency. Another one is touching the product portfolio, and then we are a little bit concerned about the market acceptance. We could smile a little bit with, let's say, the reddish cement that are a question for the use of calcined clay. But okay, this is the product portfolio, and is very variable depending on the areas. And then the use of alternative fuel and possibly the waste heat recovery. But all of these different categories are providing significant abatement, and are all some already existing and available technologies. If we look at the FIV technologies, we have divided, let's say, in two categories. This one is called the short term, but mainly because it is already applied for more than 15 years in many cement plants. We are talking about the pyroline efficiency. Let's say the last 50 years or more have seen the wet lines converted to dry line, and to dry line with preheater and precalciner. So there is some room of improvement through this part of the plant. There is also the switching of fuel. So in this case, for the calculation here, it's based on 50% on RDF. Of course, there is the matter of availability, the competition between recycling and burning. But so the figure is 50%, and a grinding technology to save energy, to save water, and possibly increase the cement to clinker ratio. And with this, let's say, easy and already existing technology, more than 20% abatement possible in the cement plant. What I will introduce today and detail a little bit more in the second part of the presentation is the more recent development that we have specifically made for these ambitions of CO2 abatement. One on the bottom left is the clay calcination. So I will go more in detail, but which allows to produce what is so-called the LC3, so cement containing only 50% clinker. So it's a significant saving in terms of CO2 emissions. Also, the evolution of the pyroprocessing technology to increase the possible amount of alternative fuel use in a cement plant, whether it is biomass or RDF. And last but not least, the concrete recycling. So it's a business that is, let's say, at the border between the cement industry and the construction industry. Nevertheless, there are applications that are more, let's say, adapted to the cement industry, and I will tell you why. But with all these technologies, at the end of the day, we offer today the possibility to reach almost 300 kilograms of CO2 emissions per ton of cement. which is quite, let's say, a strong push in terms of CO2 emission reduction. We say 65%. So you see, you have a very large panel of solutions that you can implement step by step with a different level of effect, but at the end of the day, which will allow to reach this ambitious target and have a limited amount of CO2 to dedicate to these new technologies that are known to be costly and energy intensive. So you see, we have, let's say, this slide to give a, let's say, highlight on the product in our portfolio having all an effect on the CO2 abatement. Whether we talk about grinding technologies, whether we talk about pyro technologies. What we like in this slide is, in fact, each equipment has different fields of actions. So you find here the 4 families that we had in the first slide. That's why we like this slide, from energy efficiency, fuel switching, material substitution, and CO2 capture and storage. This fourth column, without going to the very expensive projects that are already ongoing into Heidelberg for storage or oxy-fuel, we already have some solutions to capture CO2 and store it. That will be the topic of my last slide. So the 4 main technologies I will introduce to you today is the Oromill. It's not really new, but it remains very interesting, and we regularly find new advantages in the Oromill grinding plant. I will give you a short view also on what we can do with alternative fuel, the clay calcination, which is, I would say, somehow recent in the cement industry, but not really recent on the industry, and the Rodax, which is a crusher for the concrete recycling. So if we go on the grinding plant with Oromill, so the mill has been developed in the, let's say, 890s, so we have more than 20 years feedback now, and let's say for this presentation, for this area and for this purpose of CO2 reduction, we could split 2 families of advantages. One is related to energy consumption. As soon as you produce electricity with fuel, gas, or coal, you emit CO2 when you use electricity. And we achieve significant savings compared to other known technologies. In such extent, you see that typically a cement plant built by FCB with FCB Oromill at raw grinding and cement grinding consume only 70 kWh per ton of cement. And the thermal consumption as well has an effect on the energy, because typically the drying of this mill is made also to be very effective and limit the energy consumption on the thermal point of view. The second main family is the quality of your cement, and the goal here is to optimize the cement to clinker ratio or the clinker factor. It depends on the region we are talking about. The goal being to substitute as much clinker as possible with alternative material. Without going to the calcined clay, we already achieve cement to clinker factor equal to 1.8 in the Philippines using pozzolana and fly ash, so which is very interesting in terms of CO2 emissions. But also, to take the same topic than Dirk this morning, it's also interesting in terms of money, because the pozzolana and the fly ash costs far less than clinker. So the economical balance is also on the win-win side. And also the technology allows higher quality with the same blade. So in fact, you spend less kilowatts per ton to achieve a similar quality of cement. As I said, we will have a short view on the alternative fuel. So this morning, Dirk told us about the possible savings and the let's say, economical context of using alternative fuel, competition between recycling and burning. The The idea here is to show you the various possibilities you have to introduce alternative fuel in your cement kiln, whether it is at the precalciner itself, for, let's say, rather fine material. You see in our precalciner, we can go up to 150 millimeters in 2 dimensions. You have also the possibility to introduce a small amount in the smoke box. You have also the possibility to introduce alternative fuel in the main burner. But you have also the possibility to introduce coarse alternative fuel. And when I say coarse, I speak about 400 millimeters in a dedicated calciner, which is inline, which open a new, let's say, range of possibilities, reducing the needs of pre-processing of your alternative fuel. Instead of shredding to 20 or 40 millimeters, you can put 400 millimeters in your cement kiln line. And with, let's say, important substitution rate, because all these technologies, all in one, can allow to introduce up to 80% of total substitution rate. But it is clear that it also depends on the availability of your alternative fuel. But the technology is there. That's the message. Then, more recently, the clay calcination. So it's not completely recent because FCB has done a flash calcination plant in the 70s. So that's something that in terms of technology is not really new. The use of kaolinite is also practiced in the construction industry for decades. But now this, let's say, field comes into the cement plant. So what we have done in FCB is to rather give a preference to the flash calcination in comparison to calcination in a rotary kiln, to have a sharpest control of the calcination degree, and thus doing grinding before calcination. One of the significant advantages, we have heard yesterday that we have huge amount of clay available worldwide for calcination and to introduce in our cement. But clay has different qualities. Some are more appropriate to calcination and to do cement. Some are less. The flash calcination gives you a wider span of possibilities because having a sharp control on the degree of calcination, you will avoid starting a reaction of, let's say, foreign components or non-desired components in your clay that could be detrimental to the quality of your calcined clay. So that's why we went to flash calcination. We have also made the choice to go to indirect firing, which then allows the use of alternative fuel as well in this clay calcination. So that's enlarged the span of possibility to burn it. And it gives a higher homogeneity instead of the direct contact with the flame. And also, and I was joking a little bit about the color, for sure when you calcine clay, because of the iron content, you obtain this reddish color. And the market seems not to be ready to sell reddish or pink cement. So we have developed the appropriate process to keep the color under control and have a gray product that will match, let's say, the habits of the cement industry to deal with the gray product. So, and this is much more easy with the flash calcination than into a rotary kiln. So the last baby is the concrete recycling. So we have talked this morning about circular economy. We are typically into the circular economy, because the cement you produce is used to make concrete, and then if you recycle the concrete, then you have high quality aggregate to do concrete again. You have sand to do concrete again, and you have cement paste that you can introduce in your cement kiln in the limitation given by the chemistry of your raw mill, for sure, but it can be used as well as additive for cement. The benefit is first that the sand, so the 125 micron to 2 millimeters fraction, contains, you see, about 20-25% of cement paste. This cement paste is composed of calcium carbonate that has already released its CO2, but which will put in contact with CO2 will reabsorb the CO2. So this sand is a carbon sink that can be used to absorb part of your CO2 emissions. And the fines are as well, if you put it in your cement, will reabsorb CO2, so it also acts as a carbon sink. So this application of this crusher, which was originally for very hard and very abrasive material in the mineral industry, it is used to grind silicon metal, to grind titanium slag, is also applicable here, and it is very virtuous because you have 100% recycling of concrete, and you can use this material either in your process or in CO2 absorption as a carbon sink. And all these technologies are available, already used for, let's say, decades, but just recently applied to the cement industry. Here we are.
Merci beaucoup. Thank you very much indeed.
You're welcome.
Now, Loïc, I'm going to say that you're going to be talking about this in the workshop this afternoon, correct?
We can do so, but we can do here if there are some questions.
We're under some time pressure at the moment. That's why I'm asking, because you've got an hour and a half when you're talking about this with two other speakers in the workshop. So there can be more detailed examination of the kind of things you've said. Has anyone got an urgent question at the moment? Anyone got a... There's no hands going up. So look, can we leave it there for the moment?
Yeah.
And you talk about it in the workshop, because then I can go to our next speaker as well. So thank you very much indeed. Thank you. Let's go to Junpu. I hope you're still there, Chief Expert for Sinoma Energy Conservation. I hope you're there. Junpu, welcome. And please, the floor is yours. You have about 100 people in the room listening to you, so go ahead, please, for your 10 minutes.
Good morning, good afternoon, or good evening for everyone at the WC conference. My name is Junpu from Sinoma Energy Conservation Limited. In short, we can call it Sinoma EC. Today, I am very glad and honored to report about the efficient waste heat recovery technology for cement plant. Firstly, kindly please let me make a brief introduction of Sinoma EC. Sinoma EC was established since 1980s. It is a holding subsidiary of China National Building Material Group. As a comprehensive industry company, Sinoma EC specializes in energy saving and environmental protection engineering, clean energy engineering, building energy saving materials industry, and new equipment manufacturing. In 2014, it was listed on the A-share main board of Shanghai Stock Exchange. Sinoma EC is the global leader in the design, manufacture, and supply of WHR system, highly suitable for distributed power generation. Up to now, we have 334 WHR project reference in China and 68 in overseas. Here somebody may ask, what is WHR? In the cement plant, one typical WHR system normally includes pH boiler in preheater side, AQC boiler in cooler side, turbine and generator department, cooling water tower or air-cooled condenser, and chemical water treatment, etc. The waste heat source normally includes the waste gas from preheater outlet, the hot air from cooler vent, the radiation heat from the rotary kiln, and the waste gas from bypass system, if any. About the WHR technology, there are two main categories in the market. One is the steam Rankine cycle system, we can call it SRC, and the other one is the organic Rankine cycle system, we can call it ORC. The working principle is the same. Both are based on Rankine cycle, but with different working medium. For SRC system, the working medium is water and steam. which is suitable for the plants with rich water. For ORC system, since the working medium is thermal oil and organic fluid, it is especially suitable for plants where the water is in shortage. For the cement plants with flue gas temperature less than 400 centigrade, the efficiency of both are almost the same. Following, I will introduce some features of the latest SRC-based WHR technologies in cement plants. High performance. If the K-lane system adopts 6-stage preheater, as we know, the heat consumption is very low. Under such conditions, the power generation of WHR system designed by us can still reach 28 to 30 kilowatt per ton of clinker, and the self-power consumption rate of the WHR system can be less than 5.5%. High-level integration. In our latest WHR system, AQC boiler is one part of the cooler and shares the same foundation and platform with the cooler department. AQC boiler adopts the bottom area inlet, which is directly arranged above the grid cooler and connected by the middle tapping solution. Compared with the last generation WHR system, the boiler inlet air duct becomes shorter. Then the temperature loss and the pressure drop gets smaller. P8 boiler intakes the waste gas from the preheater outlet and operates in series with the K-lane system. The designed exhaust gas temperature can be less than 180 centigrade and controllable. High-level intelligent. Advanced wireless communication technologies have been utilized in the system, with which we could realize the remote big data analysis and management. A large number of HD cameras are equipped to monitor the whole WHR in an all-round way constantly, with which we could give operation and maintenance suggestion timely. Through optimizing the regulating circuit and the DEH system of WHR, we could realize the automatic control of turbine. Through utilizing automatic chemical water treatment, large numbers of motorized or pneumatic steam and water valves, remote instruments, online sampling system, and automatic dosing device, we could achieve less operation staff and high system efficiency. So only one staff per shift is enough for the entire WHR operation. High reliability. Considering the low gas temperature from the 6-stage preheater outlet, we adopt the combined superheating technology in AQC boiler, using the hot air from the clinker cooler to superheat the low-quality steam from P8 boiler. In this way, we realize the multi-stage utilization of waste heat resource, effectively improve the thermal cycle efficiency. At the same time, high-quality equipment and suitable dust removal methods can ensure the safe and stable operation of WHR system. Now, let's come to the ORC-based WHR system. As I mentioned above, the working mediums are thermal oil and organic fluid, which is more suitable for the water scarcity areas. Normally, the ORC process includes 3 parts. The first one is waste heat recovery from plant by thermal oil. The second one is the heat exchanging between thermal oil and organic fluid. The last one is organic cycle for power generation. Based on the physical parameters of organic fluid, different from SRC system, there will be no risk for blade erosion. If ACC is applied for the cooling system, no water will be consumed for the entire WHR plant. Another feature of the ORC is that it can recover lower quality waste heat. For example, the gas with temperature less than 150 centigrade. So whatever the waste heat quality, or the water situation may be, we all can provide the best WHR solution accordingly. In future, we will try to apply more and more green and low carbon technologies such as solar energy, wind energy, geothermal energy, and energy storage, etc. Our final goal is to realize the balance between the power supply and the electricity user through a smart energy management system. That's all my report. Thanks very much.
Tao, thank you very much indeed on using wastewater to generate power. Now, would anyone like to come back immediately and just check with him on any of the detail that you heard or any of the detail that you saw in those very comprehensive graphics? Please, let's get the microphone to Ian, please. Anyone else? Do I see any other hands going up? Ian, of course, spent many years in China. Anyone else want the microphone?
Thanks. Junpu, I just wanted to ask about Sinoma's experience in installing the ORC systems. Do you have any systems already installed, particularly in the Middle East or indeed in China?
Sir, so far we have cooperated with NG for one ORC technology-based WHR system in UAE, Lafarge Emirates Cement company. Now it is under construction.
Okay, thanks.
Anyone else would like to come back? Please, yes. Get Ian across to your right. Thank you.
Hi, sir. Just I want to ask if after operating the turbines by heated steam, okay, the cold water is condensated. Can it use as purified water?
Sir, can you pardon? Which part you mean water?
The water after operating the turbines.
After the working of turbines, the steam will be condensed by the cooling water condenser or the air cooling condenser, and then by the CEP circulate back to the aerator, and then by the feed water pump to the boilers. So, what do you want to know about this part?
What I want to know is, after turbines, the water condensated and return it back to the system, okay? But it's purified water because it condensed from the waste air, okay? And it goes to steam, which is pure, then it comes back to the system again. There is any system can utilize this water to be purified water or drinking water?
You mean you want to drink this water?
I want to purify it because it's already condensed again.
You know, this water, of course, it is purified and very clean. But you know, in the system there are a dosing system in there. So the water, even though it is purified, is clean, but we don't suggest for drinking or the life purpose use.
Okay.
Does that clarify your question? Does that clarify your question? Does it give you the answer you were hoping for? Good. Yes. Okay. Anyone else, please? All right. Well, look, what I propose is, Tao Junpu, thank you very much indeed for joining us from Shanghai. Much appreciated. And we will take a break now.